We are set to go now.
All right. Let's just share my screen. All right. Good afternoon. I hope screen is visible. Hello. Yeah. Hello.
Yeah, the screen is visible.
Okay. I just look for another computer. I wanted to use my phone. So, welcome to this session. I'm currently working at i3C, that is Infinity Computers and Communications Company. So, due to time factor, and to go straight to today's session, I want to tackle basically two things, but I want to start with DNS security. I wanted to start with this, but I think I'll come back to this. So, presentation is boring. you know, I did this very fast, but so, as we all know, DNS is very key to the internet. Rather, you would even consider it to be the backbone of the internet. So, but before I even go further and talk about its security, what is it itself? In simple terms, I would say the DNS is, look at it as a phone or address book of the internet. This is where you store your IPs or source records and map them to the respective names. So what DNS basically does, it acts as the interface between the human and the computer. Now, the human cannot memorize utilize numbers all the time. That is in the form of IP addresses. Yes. But that is user-friendly to the computer. So what is user-friendly? Oh, oh, oh. You can increase this volume a little bit. Can you hear me clearly now? Trying to volume. Okay, thank you. Now, I was still saying, as humans, we are not very good with this. Now, the DNS helps us do that. But if I'm looking for a resource on the internet, it could be a website address, for example, google.com. It has an IP behind it. It is mapped to an IP. Now, if I am given that IP and say, okay, 172.4.8, use that for example. Definitely, that is going to be very hard for me to grasp and put in my head every time. But if I am given a name as google.com, it becomes very user friendly. Now, the DNS has translation processes that to help us see whatever we see. But if I request, I make a DNS query, it's going to go through process of resolution, and then I'll be served. So this process happens at a very good speed. You could not actually know, but that is a brief on what DNS is. Look at it as how you save contacts on probably phone. That is how it works. So whenever you want to call, look for my number, you just look for my the phone will do its magic. So to proceed, DNS is also vulnerable to many attacks, and security is important. We are going to take the information of the DNS data as very crucial to the operations of the internet. We realize that DNS has facilitated a lot of activities come down from e-commerce, e-payment solutions, even applications using networks, ISPs, all of them use it. Though it seems not to be very visible, the presentation, but back down there it's actually very visible. Now, DNSSEC comes in to provide that level of security. So I just want to give this DNS, the SEC is actually DNS domain name security extension. Now, what is it? This is the specification, suite of them. It just adds another layer to the. Now, DNS originally wasn't actually security was considered as a serious factor by that time. But now, DNSSEC comes to implement security to the DNS. Now, it helps to mitigate a lot of things. Talk about things like authenticating DNS responses, talk of things like DNS spoofing, and the rest. Now, DNSSEC handles that. So it uses, how does this work? It basically uses what you call the public key cryptography to verify DNS. Simply say, it uses digital signatures. To verify the integrity of the data. So when you look at the integrity in terms of CIA triad, you get to realize that this is what DNSSEC, that corner of the triad is what actually DNSSEC is trying to do. Now, why does this matter so much? You realize that there are threats, of course, such as cache poisoning. Look at it, for example, let me illustrate it. If there is a pipe, probably water pipe, that is, of course, used to supply water. If that pipe is actually not buried underground, it's not very secure. A car could step on it and it ruptures. It is just prone to a lot of destruction. Now, look at that pipe as a channel through DNS that is passing. If I accidentally open that pipe and put in impurities in that water becomes impure. I poison that water. Wherever that water is reaching at that moment, it's actually poisonous to the consumer. Now, that is how I can illustrate cache poison. So, cache in itself is stored in memory, it's temporal. What this does, it reduces the DNS process. That if I am to query a server very far from me, if I have a cache, a resolver, that is going to actually serve me that data. Now, how that is updated, I don't really want to go much into detail on that, but how that is actually updated is what you call a refresh time in the DNS zone. That refresh time is the one that actually handles how cache is going to, the duration of the cache in that result, or what we call the DNS. Now, there is also spoofing. There is man in the middle attack. You could look at it as the same way I interpreted cache poison. So this brings us to issues of unsigned and signed. Let me now illustrate. Sure. Then I will take you through what we call unsigned in a moment. All right. I'm going to use the tool. So as we wait for this to load, let me proceed and explain what digital signatures do in terms of DNS. So digital signatures add what we call a signature to the existing record. Now, there are resource records called MX records that handle records, IPs, the names of canonical records that help to map one domain to another. And these signatures are stored in a new record. Now, that record is called the resource record signatures. And there's a DNS key. And how that works, I am also going to. So each DNS zone has a public and private key. So the private key is used to sign the DNS zone. And then the public key is used by the DNS resolver to verify that signature. So what happens if the signature is invalid? I will also talk about the consequences. Now, this helps us to establish what we call a chain of trust. So when a DNS resolver makes a query, it can only validate the digit of the result. Now, the validation process goes up the DNS namespace or the hierarchy from the child domain up to the parent domain. Now, in this case, you'll see, for example, if I say .ug is a namespace, but it's the child. So when I talk of the dot at the very, very top, that is going to be the root. It becomes the parent, okay? TLD, which is UG. Now, that entire validation process goes up to the parent and so on. Now, all the way to the root zone. Now, the root zone is the dot. It's invisible most times when people write, for example, say google.com, there is another dot in front of it. That dot represents it. Now, there is also another record called the delegation signer record, which has a hash of the child zone. Now, in the child zone, that actually helps it stores that public key that it is stored in the parent. Now, this allows the resolver to verify that key. So it's like the parent has the signature, what you call the private key, and then the child has the public key. So for the child to access the parent, there is going to be a key. Now, this is stored there. Now, this allows the resolver, would call it in simple terms the DNS to verify the key of the child. So when a query is made, the child asks, you get it begins from the parent coming down and the same process repeats itself. So until the record is valid. Now, what happens when the response is not valid? So if the signature validation fails, what happens basically? The resolver knows that the data is not authentic and that response is dropped. So basically, you don't get any response. It just returns null. Now, this prevents the user from being cause malicious. For example, if I am to redirect your domain to another malicious site, and it is a signed domain, if it has the key, the signature, then that is going to be a little bit impossible because whenever it tries to verify, it is going to fail. So let me proceed and just I want to query this. This CD is actually the namespace for Democratic Republic of Congo. It's the one I'm going to be using. From my recent checks, realized that CD is actually not a signed zone. and we are going to see that. Let me update this. Right. Okay, are you able to see this clearly?
Yes.
And this, the errors are, and you can see we have an issue with the DNS, then the warning. Now, what I want to explain what this diagram is thinking. You can see this. We are already having errors and warnings. I want us to explain this. I'm going to explain two. One, this is the unsigned zone, and I want to help you see where I'm getting that from. Let me open website. DNS Tech Africa.com org. Okay, so I want us to see this, how I'm getting it. This is cd.cd is the namespace for the Democratic Republic of Congo. This zone is unsigned. It has not published, it has no key, it has no DNS, it has not submitted any record to the zone. So I am going to pick this and I will talk about that. So this is what we are analyzing. So when you look at from the top here, moment. Oh, right. So when you see this diagram, basically is illustrating the DNS sec validation process for this domain. This domain CD, Democratic Republic of Congo. Now, when you see it depicts, it depicts here that we have a chain of trust. Now, the key, this DNS key is basically showing us is a query for a DNS key and the subsequent validation of that very key you get. Now, at the top here, we can see we have this ID. We have the key signing key, which is we have the key signing key, which is the public part of this key. Oh, okay. And it's hovering. And yeah. Just give me a moment. Okay. All right. So I was just saying that this diagram illustrates the DNSSEC validation process. Now, this there is an anchor here. I want to really first try as much as possible to simplify this. So we have this DNS key, that is the zone signing key. And these are also zone signing keys with their IDs. That. So the gray shaded records, these two guys, those two guys, they indicate that those specific keys are being used for the validation. Yes. Now we have a trust anchor. This on my right. Now from the trust anchor, the path leads to two DNSSEC records, which is this, the start of authority, and then this, the next secure. Now, the SOA record provides authoritative information. Now, this information, when you hover on it, you will see that it is talking of the TTL, the root servers, and all the IPs. It talks of also the status. All that is in the SOA record. When you look at the NS record, this record is used in DNSSEC to prove that the non-existence of the DNS. Now, it's the one that creates the chain of all the records or the record names, which the validator can use to then verify that the requested record name is present. Now, when we come down here, you will realize that at the bottom here, you see that it clearly shows that there is a failure. All this shows that there is something wrong. There is failure in the validation. Now, these red warnings all show that the domain has failed to verify the signatures. Not that the domain has failed or it doesn't, it's not working, it's working. But what this means that the signatures have not been found and cannot be. Now, the specific records basically show that when you see CD SOA and CDNS, along with, of course, its warning signs, just indicate that the signatures are not verifiable. They could exist, but they are invalid, or they are actually not just there. Now, that basically brings us to one thing, that this zone, the CD zone, is just not signed as yet. And probably, actually, also another thing that could cause this, leave alone being unsigned, could be that at times the SOA record is inconsistent across the name servers that serve that particular zone. Now, when we come also here, I'm going to just do a simple validation test here. One test. Okay. So basically, that is what all this other side means. That whatever we are trying to verify is not found, and if it's not found, we can't verify it. Now, it doesn't mean that the domain is not going to work. The domain is going to work, but of course, this exposes you to vulnerabilities. You are vulnerable to attack. So it's like trying to give me a document that is supposed to be signed but it's not signed. So there is a way that I may not trust the document. So not until it is signed, then I can trust it. It doesn't mean that the CD namespace is not working. It is working, but it is just not secure. Let's come back here. So from our test, you're going to see that we still have the same errors. Let me just focus on this. And you can see that the child does not have at least the name server going to resolve IPv6. This basically means that it's not considered to use IPv6. When you also look at the name server authoritative, this response was not authoritative for the UDP port. That when you come to this, test this, when asked for the SOA record, this is now where we'll come back to, and it shall say this zone has issues. When you come down here, this is basically showing us that when you query this for this, the server is not responding. This basically failed. So this basically shows you that we still have a lot of issues that is on until it is signed. And that's when actually most of those errors will be corrected. Now let me also pick a zone that is signed. I want to pick the zone in Sweden, dealing with Uganda DNS forum. So query from it here. So this is actually basically trying to illustrate the point in the slide of why DNS security matters. Because once you have unsigned zone, it's vulnerable. It can easily be misconfigured. And all this could lead to big outages, very huge outages. I think recently there was an outage, but not related to tech, though it is something you could say. That was in South Africa, March 2025. The ZA namespace got affected. But the one that really maps to this particular incident was the one of .ci. That one is the Cote d'Ivoire, Ivory Coast. And it had the same issue. And when it was being queried, it had no signatures. And it got misconfigured in the process that brought it down. Now, we are checking ours. This is the UG zone. I'm going to open these warnings and I'm going to explain this also quickly. Now, the same thing literally from the top. Okay. So now I'm going to pick it from this. That's where our anchor is. So when you look at this, we have an algorithm that is actually a response to activity. So in this case, when you look at the UG zone, remember the CD zone never had a DS. Now, in this particular zone, you can see that there's the delegation sign out of the DS report. You get that alone, actually, when you see it on this diagram, is enough proof to tell you that, you know what, this zone is signed because it has a DS record. So this this shows that our zone as a UG zone. Now, remember what I talked about previously, that this DS key, yes, is from the child zone. So the parent zone, in this case, publishes DS record to link it to zone UGNet. Now, this record effectively just delegates trust, just creating what you call a chain of trust. Yeah, from the parent to the child. Now, when you look at the diagram, it basically just tells you that the DS record is linked to the child. So when you look at this is our root. You can see that dot. That's the parent, and this is the child. You get. Now, this guy is the one linking. It's basically saying build, just establish trust between me and the child. You get, with of course digest. I'll go through that with the algorithm when you come and check it. Other diagram. Here, UG. When you come and check UG here, this is what that means. The date first was published to the zone. So you realize that we already signed. Now, when I move to this other section at the child level, you realize that the name server specifies authoritative names for the domain. You can see that our Anycast have so we have Anycast, we have all these are our authoritative name servers for the UG. So there are 5. When you look at the server here, it provides administrative information, who does what, the contact, and all that. And the same applies to this. Now, when you come to this other section, it is used basically to authenticate denial or existence. And it provides, it proves that the requested record does exist or does not exist. Now, in this case, this exists, and it shows that there is no leakage. So, how can I explain leakage? All right, so that's just basically to take us through why DNSSEC matters. Now, in case an attack is to happen on this zone, it could be challenging. Yeah. Now here, this warning basically shows that the blue record exists for this, but they are not corresponding to the authoritative. Now, this could be caused basically by either a misconfiguration in the IP, that is the IPv6. It's published, but it's not linked. It's not yet. It's not linked to the server, the name server itself, or it could be linked, but of course there is the store refresh. It's taking longer than usual. So most times you see when you refresh, it then clears. So basically, this illustrates the entire validation, DNSSEC validation process for unsigned zone and a signed zone, and what is present in the signed zone and what is not present in the signed zone. So when you check this, you realize that in this signed zone, we have the DS record that published, and when you check on the DNSSEC website, we are already having that information verified. So this is the third-party script. When you do the same for here, realize that the inconsistency is still coming from the other glue record we're talking about, and that is the same thing we are having here. So we're just having one simple issue. That is just the glue record, the IPv6 address. But in terms of DNSSEC, we are good. So going back to the slide, and I would like, I think, to summarize this. You realize that DNSSEC basically adds digital signatures to the DNS record and ensures integrity of the DNS data, and also authenticity. It creates a chain of trust from the root. In this case, this is our root. The root is this top guy. It establishes a chain of trust between the root, the child, and any other sub-level domain that could be .co, .ug, all that is now going to be trusted in the DNS validation process. So the tools basically we use, I've already used most of them. That's DNSV, the zone master. Of course, there are others, but these are I would say, the easiest ones to use. Most others are on the command line. And that, I think, brings me to the end of that section. But before I close that section, there is something I would just like to say. The DNSSEC deployment is a process, but it ensures that the DNS is actually DNS data is actually safe. And also another thing that now goes to administrators, they're what you call the SKs and the ZSKs, those are the keys. Those ones most times are regularly updated, just like the way we would say password rotation. Then what we just did actually is like monitoring validation across resolvers using the tools I just used here, which is Zone Master, DNSBs, and other DNSSEC Africa.org. Okay. All right. So let me summarize this part and then probably go to the other section quick. So in just summary, the process, this entire DNS validation process, for this case for the .ug, just helps us to know how safe we are. This takes us back to what we call monitoring. There is no specific dashboard, but internally we have simple tools that we use. We have incorporated in our infrastructure that helps, check for some of the issues. Some of them it's just routine maintenance that actually brings to show how we are performing. So, summary, basically, DNSSEC helps us to keep our zone as secure as possible. Though there could be a way that it's not all that full. This is at the parent level, but at the user level, of course, we now encourage users. First of all, you can have a signed zone like this one, but yet your user data or the zone, that is the domain name, for example, I would have edward.co.ug. When it is being submitted to the zone file from an authoritative name server that is not DNS compliant, that is also a challenge. Now, those are a few of the challenges we're facing as a probably country. So I think that was just by the way. Let me go back and open. Yeah. So let me go back to talk about infrastructure reliability. Now, basically, infrastructure, I could say, is a fancy word, but this means, of course, the servers, the tools that are used to implement this DNS technology. Why reliability matters, of course. I don't think anyone would tolerate unreliable services. Imagine you're using the URI portal. In Uganda, we have the URI portal. I think it's one of the most visited portals in the country. Now, imagine the i3C subdomain is misconfigured. That, of course, would break it. And once that breaks it, meaning that service is going to be down. So this is why reliability probably matters. Look at when you send an email anti-bouncing, most times it could be DNS, it could be an issue with network, but most times I can say it is probably either misconfigured MX records. Now, MX records are not that handle email vulnerability, both from the sending and receiving domains, of course. It could also affect services. And now, if, for example, we have servers that are not reliable, or probably servers that are designed in a way that their load capacity is small, and we are exposing it to the public, that is basically going to, some people will access it, some people won't access it. And of course, sometimes I believe some of the things that we by us find that some services are not reachable. And if they're not reachable, that is already a sign of reliability. You can't rely on that. That service is not good enough. And it could be crucial. Now, I talked about there was an issue with the CI domain that happened in, I think, 2023. This other one was just so recent. That's actually put it in the slide. And you find that in Uganda, our challenges basically are not very far from this redundancy. Now, redundancy, I would explain in a sense that I have one server that is serving a particular service, and then I have another other server having everything that the first one has or the primary one has. Just in case the first one or the primary one in production is hit, or maybe by a DDoS attack or a network outage, then I am going to have another server that is going to come in play. Now, most times in the design, what they do is there is what you call load balance. You find that there are 3 servers, 2 are redundant. They're just waiting, just in case of anything. Now, in Uganda, most times that's the challenge because it comes with, of course, a cost implication. Yeah. So that is going to affect even the uptime, definitely. Because if we expect the server to be on most of the time, there are times it is going to need to probably put the service. Now, without redundancy, of course, we are going to have a challenge because I could want to update this other one and the load is being served together. So uptime is also affected. All right, so let me move down and talk about things like, all right, tools for reliability. Bind9 is widely known. It is one of the most used DNS software on the internet. And it's used even internally. But on the other end, most times I would say that it needs a certain level of competence to handle it. But it is widely used. It is actually used on some of the servers, like the F-root uses Bind9. There's Power DNS. Power DNS is quite simple. It can be used to run authoritative name servers. If time could allow, I would have taken us through the process of how to install this, how to configure it to be a primary, and how to configure the other to be secondary. But anyway, Power DNS is lightweight, and it is now very more adopted than I think there's some other one I forgot. So these are some of the tools that we use to create a certain level of reliability. Now, look, we have a primary that is running on Power DNS, and then we have all each secondary is also running on Power DNS. All of them are configured to communicate. Now remember that in DNS, in DNS, any of them that is configured to give authoritative responses will work. Doesn't matter which one. Can give it 1, 2, 3, 4, but the order doesn't matter. So Power DNS is that tool that you can use use those authoritative name servers for actually the user domains. That is the domain names that are people are more familiar with. So their authoritative name servers are built on that tool. It's actually open source, just like Finder is open source. Now, DNS Python is a scripting library. Now, this one needs you to have some Python programming skills, but the scripts are not really complicated. So some of the tools that we use, you can use DNS Python. You can use it to query for DNS. I mean, for DNS, you can also use it to update a zone. So all that. Those are some of the tools that are mostly used. But of course, there's preference and ease of use, and of course, also how competent the person is in tools. So I have not put the links, but I'll prepare this better and I'll share. Now here we are going to skip how to install this, but I'm going to just open my terminal here briefly, and then I show us how Power DNS actually looks on the back end quickly. I don't know. Oh, I can do it very fast. Give a moment. Let me Apologies, I'm failing to test this. Demo this. Test it. Change my network. Challenge. Test it. Anyway, I think let me just proceed with something else. I failed to access the primary name server on this. So what I just want to demo here quickly is how, for example, to search for zone data, how you get into so I believe this is very visible. So I just want to show us how we access this. I'm using the Linux subsystem. So this just simply. So say for example, we need to find the lead is the most tool, just a tool actually, used to query or maybe look for example, if someone calls me right now, my website, yeah. So basically, we start with saying, if for example, let me use i3C. Okay, let me actually use the DNS forum. DNS forum.ug. I will first have to find out its status. Now here, it should show me that it's active. If the customer tells me my domain is down, I'll have to first check why it's down. I'm querying the ccTLD registry, and it shows me the details of the owner and the person who registered it and all that. But if I get to know that it's active, meaning on the registry, it's actually on. And then I have to find out why is it not, probably the DNS is misconfigured. So I'll now have to look for why, the reasons why. Now I'm going to, for example, query this one. Don't mind of the commands. DNS forum. What I'm trying to say here is, please get me any record. So in this case, I'm querying, and it is giving me. So in this case, it's giving me this IP. Now I know that this IP is mapped to it, but still telling me it's not up. What could be the problem? It could be a wrong IP. Yeah. So if it gives me an IP like this, it means it's active. So I could also just say it could be active, but the IP is wrong. I could just try and do some other check. Let me say this an IP. It is responding. I'm asking myself, what these are just troubleshooting techniques, just to know where this particular thing is located. Now, let me clear this just to make it a little bit tidy. Now, let me again say, this particular client has again called and said, no, now that you have resolved my issue, I could probably go to the IP and remapped it, and they tell me, but I'm having issues with, okay, before even I proceed that, let's say we get to find that it is not active, and then I have to query it again. I'm now querying and I'm asking it, I'm querying any probably name server. I'm like, give me anything to do with DNS forum.ug. But this time I am very specific. I need you to give me the NS, which stands for the name server records. And then it tells me the name server is authoritative. So assuming that the previous IP was wrong, I am going to still ask it, show me that IP. And it's telling me that's the IP. I'm like, okay, I am going to interrogate now each of these name servers and find out what could the problem be. You may find that the IP is only here and has not moved to the secondaries because these are all the secondaries. So I am going to say, I'm querying this guy, but I want to interrogate specifically this name server. That name server is authoritative. And it's telling me I have the record. And then again, I check here and it tells me, let me wait and see. Now you can see, tells me there's a communication error. However, I have an IP. Okay, we could go and check 2 and 3. 3 tells me that's the IP. And then I also check here. Now, this is basically just finding out what is the IP of this particular domain. And then when I get to know that IP, if all this is working, probably it could, maybe you could now blame the server in case. You could say, oh, maybe it's the server that has issues. Let us now find out which server it is. We could say, all right, let me just run a next lookup. I'm like, who owns that? Then it tells me, okay, this particular person. And then now I have to go into this server, and I do whatever I'm supposed to do, and then rectify the problem. So that is for the case of that, and that could also work for other DNS records. They are very many. There is also MX. Now this MX basically shows us what the primary domain, primary mail server. This happens to be Google. So meaning this particular domain is using Google. We could also query any other record that comes to mind. We could also say I want to find the SOA record, and it tells you actually that is the SOA, and all this information we have it, and you realize this is the guy that we are actually looking. Now this SOA record. I just want to talk a little bit about it. This is what the primary names, the secondary name servers always contact in case of any change. So in case this changes to 3, the secondaries, which happen to be DNS 1, 2, 3, and 4, will then send a request here. Now that request is based on this guy, which happens to be the refresh time. That after every 3600 seconds, please check for an update. So this is very important, and should this be misaligned, we are going to have a problem as well. So that's also something I want to make. I think another thing. So just showed you a few things, how you can resolve a domain, just by a terminal, and then of course identifying authoritative server in that through terminal. So let me just conclude by talking about some of the best practices. Currently, you find that for our case, we have 5 name servers for the UG zone, and one of them runs on Anycast for resilience. Now, what Anycast does basically, it leverages the mechanism whereby not only one server is giving response or is rotating. In case one goes down, Anycast does the entire. It's called Anycast routing. There's also what we call geo-distributed authoritative servers. We don't put all of them in one region. We put one, for example, in Uganda, one in the US, UK, yeah, and they're all there, but they have to communicate. So that also helps us to maintain what we call reliability and availability. So we always also, actually, these are monitoring tools also. Grafana is also used to monitor. Automating. I talked of something to do with load balancing, but this one happens basically during in the design. This is not something that we see on the interface. It's in the design. So what the takeaways from this, or how then does the hackathon benefit from this? Of course, I would say if there is going to be a very big output, this actually a project that would not only be done in a day. You'd have what you call a redundancy checker, and be built probably in Python, or you can have a script that does for you, just like we saw on the other DNS website. All this could be scripted, or we could have what you call open source monitoring tools, and then we set them up and they will do for us all this. Now, one of them is Grafana. There is also what we call Nagios. I think there's also NMS. Those are all used to monitor. Now, if only time could allow us, I believe I would be in position to see how to set up an instance and configure maybe an open source, like open source software, like probably Grafana, the community version, and then use that and then monitor. Now, that is how we also make sure that we are in the know of whatever is going on. So I think from my end, that is all I had to present. I know I've really jumped, I've gone through this quickly, and probably some areas may not be very clear, but I'm going to try as much as I can to have this slides polished and probably shared with Cliff. And then, yeah, we can proceed from there. So from my end, I think that is what I had to talk about in regards to reliability for DNS, DNS security, and the tools to be used, the best practices, and where we are heading. But a keynote to also to just finalize this, you're going to realize that in terms of the DNSSEC, we are actually already good. So I've already seen that for yourself. So some of those links I'm also going to put them in the slide. You realize that Uganda actually, our zone was signed way back in 2010. We have never had a major incident or a major outage of our UG namespace, which is a good thing actually. And this could also speak a lot about how stable, how reliable our DNS infrastructure is. But we still face other challenges. And those could be challenges coping from probably adoption, of course, awareness. Yeah. And also, of course, some of this infrastructure is not cheap. That's why you find that some ISPs or probably some companies prefer still using the legacy ways and all that, as long as it's working. But with the legacy, we introduce a lot of vulnerabilities into the systems, and yet DNS is very critical. Very critical. And when you look at our .ug, it's actually one of the domains that, as Uganda, we are proud of. When someone is out there, yeah, they are proud knowing that if I want a business in Uganda and I want a domain for it, we have actually what we call a digital presence. So in summary, that's what I really wanted to put across. Apologies for the little bit of those breaks. I had to change my laptop. Yeah, but I think this has been what I could share. In case of any feedback, I beg to. Thank you.
Thank you so much, Edward. It was quite a lot to learn from there. And we now want to ask if there are any questions from you, the participants, anything that you feel needs to be refreshed or clarified, please, now is the time to ask.
I would like to inquire because the demonstrations that our presenters just showed, most of the tools are demonstrated with terminal based. I'm like, if I'm trying to work around with a track of DNS security, is it all about me coming up with a certain tool that will be terminal based, or I need some clarification about that?
Okay. Let me give a insight to that in a quick way. Basically, I want to make this very clear. When you look at the initial design of the DNS or the domain name system, it was not built to run on probably Windows or myself. It was built to run on Linux. And when you look at bind in its design, they never incorporated any user interface. It is all administered via the terminal. But however, their tools and their methodologies actually are used to build a UI for it. Now, the reason why they never built the UI was the UI is so basic and it limits administrative tasks. So basically, these are not terminal based. What I tried to show was okay, on the terminal, that's how you achieve it. But I could also show you how to achieve it on the UI if you also want. Now, let me demonstrate that in a short. I am going to share my screen again, and I show you which other tool you can use. Though I don't really like using them, but they are there. I want to open up here, and I want to share my screen, and I want to show you that actually they are not only terminal tools. Those are tools that people have come up with probably because they realized not everyone is well aligned with the terminal, because you need to really have a lot of commands. You really have to have the commands. Now, memorizing commands is something that's also a little bit hard. So I see my screen. Hello.
Yes, I'm seeing it.
Okay. So I want you to, if you're on a laptop, I want you to read it yourself. There is DNS. Let me actually put this big web interface. What I was doing the other side is also going to be done here, and I'm going to show you how. I'm going to type in the DNS forum. I'll be able to see this clearly. And in this case, I am just going to specify that I want the A record. Now I want you to show me the command. Yeah. And then I am going to ask from the authoritative only. I want you to ask whether it is DNS capable, line. So I am going to say dig. I hope you're seeing this. Are you seeing that? So what this is basically telling me that this RR SIG stands for the resource record signature, meaning that this domain zone or this domain name is signed. It is submitted to the zone file with a signature that is verifiable. So these are basically the UI tools that someone who is not very familiar with command line use, and I think most people like to use. So let me ask. Let me also query this. I'm now asking authoritative. Authoritative simply means yeah. So in this case, I'm going to dig again. Now this is dig web interface. You can see this is what I've just queried, and it has told me, all right, this is the name server for the UG zone. These are 5 name servers of the UG zone. Yeah. So these name servers are the ones giving us the thing. Oh, DNS forum has this name server as that authoritative for it. Now this is the command. If I pick this command, the way you see it, and I punch it in on the command line, I'm going to copy that. I'm going to open my terminal, and then after opening my terminal, share my screen. Then I show you that what you see there is literally the same. It's just okay, easier to use the terminal. Now just paste the same type of command, and I'm querying the CCLD. This is the UG name server. Are you seeing that? It's the same thing. So it's not only that you can query it from here. Now, what they have done, this is actually built. I'm writing this command, but in here, they have already written them for you. Your work is just to tick, select what you want, just check, and then it is applied. So that is. There's another one also called DGUI. That's standing for Dig Graphical User Interface. And I'm going to also paste the same thing. DNS forum.ug. And I want authoritative. I want only the authoritative name server. What I mean by authoritative, oh, let me pause sharing. Let me share my other screen. Yeah, all right. So okay. I've seen your message. This is I am having issues. Okay? All right, let me pick this. Yeah. Okay. Are you seeing this screen? Sorry if I'm going to reply. I'm asking it for this. I'm just going to run it. So these are some of the UI tools. Now this is the challenge you're going to get with UI tool, that you have to run it multiple times because this is going to have an error. You have to communicate with the terminal. So you are looking for the error code for the zone this, and this is the name server that has replied. The same applies here. We are looking for that, and it is in this secondary. We are looking for this A in this, and this is the primary. That's how it has been delegated. That's why you see when I ask now, for example, I come and ask that I want a SOA, you're going to see what run it again, and then run it again. Now, these are the challenges talk about UI. So when you ask for the SOA, you see that there is this guy. This is the SOA record, right? And it is going to show you this DNS one is actually the primary. It's the one that is in this one. Yeah, so I think your question has been answered. Yeah, there are those two. Dig GUI, you can use that. And then you can also use, this is for DNSSEC, basically when you're checking signatures of its own. And there is also this. Now there's also one more. Let me just finalize this one clearly. There is into. This is beta still being developed into DNS platform. These are all tools people are using. Try and run away from the back end. So when you report, though you can see it's in beta, still under development, it gives you same. So here it gives you the domain name record, which are this, with all its corresponding IPs. It is going to ask for the TLD parent check. This is available in the CCTLD. That means these name servers at the parent level are able to see, and the parent level are the ones above the child. At the IP addresses of the servers themselves, authoritative for this one. And then CNAMEs are all present. He has checked them. He has also checked the SOA record, and he has already showed you that this is the SOA record. He breaks it down to show you the refresh rate, retry, expiry, and the default TTL. TTL, the time to leave. Now, this is the time it takes for the cache to expire. And then to show the entry. This is actually the primary, shown you there. And this is the SOA serial. It has just broken down for you the SOA. This is the serial, same as that. So when this is what actually updates what is responsible for the consistency across the name servers that are authoritative. And then to show this MX, it's showing you the MX record. This is Google, meaning that this domain has a mail server, which is a primary, and that's Google. And any other. The reverse MX, this is very important, and this is set automatically because we're already using the primary that Google to already set it for us. And then there's an A record that has been found, the CNAME has been found. So this is another tool you can use to check for that information into DNS.com. So let me respond to Sharif. You can actually just build dashboard just to help you query. Now, I want to get what you call a DNS and share with you. Let me just get your DNS names. You can just go on Google and type DNS namespace. Sorry. And then I'm in position to whatever diagram you get, but try and get a clear one. Yeah. Trying to get one. At both CCTLD and TLDs. There's one I have here. Okay. Yeah. As we conclude, let me just share this. Can you see that screen? Hello? Hello? Is the screen visible on your end?
Yeah, we can see it.
I'm going to confirm. You're able to see it. So, the DNS namespace is hierarchical, has a hierarchy coming from the root, that is the topmost you see up there. First. Okay. So, when you look at the root, this is the topmost level. This is actually the root. That's where it is downward. When you look at this .net.edu.org.gov.com, those are what we call. I want to break it down how it is split. So from here to here, this is the .com namespace. This breaks down now. These are the second level domains, what we call subdomains. So when I contact just know that delegation is from up coming downward. There is no down up approach. So when you look at this, I break it down to .com. So this only contains the .com name servers or authoritative. When I look for sitehousing.com, it is going to present, it's going to, this parent is going to serve me with the name server authoritative for this sitehousing.com. Now, at this level, I am going to be querying the name servers that are authoritative for this guy, that are going to give me now the site. You get. Now, when I say blog, it's going to be blog.sitehosting.com. I'm not going to go up the page. I will just end here because this one is a child of this, and site housing is a child of the .com namespace, and .com is the TLD that is a child of the parent root. I don't know whether that has clarified it. I'm getting this document from research. So that is basically how it is split. Let me see if I can get some other one to really bring it where there is CCTLD. So, but basically, how you you can get more of this on just type DNS namespace, and then you will be presented with all the diagrams. But I will be in position to share with you a detailed one in the presentation. So basically, that's how it is split. It splits from the root coming downward. Now the root only has name server authoritative for the .com. Then when you come below the .com is going to present you with the name server authoritative for that subdomain or the SLD. Then SLD will now ask the authoritative name server for the user domain. That is now the subdomain. So next time you query, I don't again have to go up. I just now query from there. Authoritative name servers for the sitehousing.com, for example. So that is how it's broken down. It's this entire tree-like structure is actually hierarchical. That's how it is broken down. So I believe with that, you are in position to clarify, unless there's any other question. Then just to also proceed and say how authority is delegated. Authority is delegated from top to the bottom. There is no bottom-up approach. It comes from the parent downward. That's how authority is delegated. And then I actually talked about this, how cryptographic keys are assigned by DNSSEC. Basically, signing it happens in a way that we use what we call a DNS record, and there are two keys. There is a zone signing key used to sign an individual DNS record. Then is what we call a key signing key, used only in the zone signing key. So it's a larger key and changed more frequently. So it's a public key that is published in the parent zone for the chain of trust. So that is how, I don't know how to illustrate that. There could be a better diagram. So how the signing works, we create what we call a zone signing key for the zone. Now, just know a zone signing key is just for the DNS record. So signing all the records in the zone using the signing produces what we call a resource record signature. Yeah. So then that creates what we call the key signing key. Now that is the public key that is published in the parent zone. Now, after signing the zone signing key with the key signing key, those two keys produce what we call a delegation signer record. Now, that delegation signer record is what is published in the parent zone. And that is how signing occurs, actually. Basically, that's how it happens. So there is a key that is signing each individual record. That is the zone signing key. Then there's a key that is signing the key. Now that key, when you combine those two keys, before you combine the two keys, there's also what you call a zone signing key that produces the record resource signature. So when you combine that, it creates what we call the key signing key, and then that sign is combined together. The two keys are combined together to give us the delegation signer record, which is the DS record previously stored, and then that gives us what we submit. And then once that is published in the root zone, your zone is signed. So basically, that is how that zone signing happens. Yeah, so basically, I think that is what I have to answer. I think if there's any other question. You're welcome. You're welcome. So to summarize, I think on my end, this slide is going to be shared. Just have to polish it a little bit and then probably share it. So basically, that's how infrastructure reliability in DNS and DNSSEC actually contribute to this DNS we are talking about. All right, back to you, please.
Hello.
Unless there's any other question, but my end, that is what I have to share. So.
All right. Thank you so much, Edward, and thank you so much for your time. And I hope we learned a thing or two. And yeah, we are looking forward to diving deeper, and we start innovating around these solutions. Now, we initially had 5 tracks, but looking at the number of participants we have, we are going to narrow down the tracks to 2. That is DNS security and DNS sec adoption. And then the other one is universal acceptance. So shortly after, we shall convene and we start the group setup so that we can start doing some actual work. All right. Other than that, if there are no other questions, allow me to wish you a nice evening.
All right. Thank you so much. I wish you a good evening.